Thank you. All right, guys. Everybody have a note sheet. So what we're doing today, so before Thanksgiving break, we went over defining what a higher degree polynomial function is, how we define it, write it in standard form, and we write it, or state its degree, type, and leading coefficient. We also went over evaluating higher degree polynomial functions. And we also went over addition, subtraction, and multiplication. So the only operation we haven't done is dividing. Now you don't have to write all that out. Really, when we divide two polynomial functions, we'll get the main part of the answer, which here is q of x. And r of x is just our remainder over what we're dividing the equation by. So, kind of what we're going to be doing. Now, whenever we divide polynomial functions, there's two ways to do it. One of them is long division, and the other is synthetic division. What we're going to be doing today is long division. What we're going to do tomorrow is synthetic. Most like synthetic division a lot more than long division. It's not because it's more challenging, it's just tedious. So the first thing we need to do with long division is set the problem up. So we'll have our long division symbol here. Whatever goes in front, or whatever's in front, the expression in front of the division symbol, or on top of the fraction goes first, or goes inside. So we'd have x cubed, x squared, plus 2x plus 8. This is on top, so back of the first page at the top, you do need to change two of the signs, because I wanted plus 2x and plus 1, just to make this problem work a little bit nicer. What it's being divided by, our x plus 1 goes on the outside. Questions on this so far? All right, guys. Questions? Guys. Yes, top drawer. Questions on any of this so far? Questions on what we've done so far?
Long division today?
So we're doing long division today, yes. Question? Question? All right. Now when we divide each term, unlike long division with numbers, we want to eliminate the first expression, our first variable, out each time. Yep. So the first term, here's our x cubed. We want to get it to become 0. We want it to simplify out. And to do that, we need to figure out what we need to multiply this x by to get it to be x cubed. What do we need to multiply x by to get it to be x cubed? X times x, which is x squared. Because we have 1 on the outside, and again, we're matching up first term and first term. I have 1 outside, I have 3 inside, so I'm missing 2. So we need to multiply it by x squared. Now I would do this multiplication out to the side. So since we found out what we need to multiply it by, we're going to multiply the x plus 1 by our x squared. So the first thing we're going to do is distribute this here. X squared times x is x to the third, which is what we want it to be. We want it to match up to that first term inside. Now our x squared times 1 is going to be plus x squared. Questions on this so far? Yes, sir. Unfortunately, no, because the calculator needs a value for x. It can't just be x. At this point here, we're going to put this underneath and match up our terms. Our x cubed goes under the x cubed term. Our x squared terms line up. We line up like terms. And then we are going to subtract. And again, when we subtract, that first term should always be 0. Because x cubed minus x cubed. X cubed minus x cubed is 0. That does cancel out. Then we go through and subtract through the rest of it. Negative x squared minus x squared. Negative 1 minus 1 is negative 2. And we still have our x squared term. Questions on what we've done so far? We're almost done with the first step. Next step, last part of the step, is to bring the next term down. So we bring down the 2x. Questions on this here? Questions on anything we've done so far? Are you ready for the next step? The next step is we're going to do everything we just did again. So we start off with the same thing here. So we're going to look and see what times x is going to give us negative 2x squared. So we're saying what times x gives us negative 2x squared. So we would have a 2. What's the number in front of our x out here? 1. So we need to multiply some number by 1 to get what? So what do we multiply by 1 to get negative 2? Negative 2. And what times x gives us x squared? X. So we're going to multiply the whole thing this time by negative 2. So we're going to say negative 2 times x plus 1. Negative 2x. Negative 2x, not negative 2. Negative 2x. Because now we're going to distribute the negative 2x. Negative 2x times x. We still have the negative 2. But our x times x is x squared. That does match up with our first term because, again, we want them to be the same. Negative 2x times 1 is going to be negative 2x. And again, just like before, we're going to put it underneath and match up our like terms. Our x squareds are going to line up. Our x's are going to line up. Questions on anything we've done so far? Questions on any of this here? And again, just like before, we're going to subtract. Negative 2x squared minus negative 2x squared. Well, really the negative and negative make a, so we really have negative 2 plus 2, which is 0. Those will cancel out. Our next one we have is 2x minus negative 2x. Well, the negative negative would make a plus. 2x plus 2x is 4x. And then we bring down our next term. Questions on this so far? And then we do it again. So would we say that there's a lot to this? Well, yes and no. I mean, there are a lot of steps to it, but the steps in and of themselves are not bad as long as we take it one step at a time. Questions on this so far? All right, let's start this again. What times x gives us 4x? All right, guys. What times x gives us 4x? 4. Because it already has the x's are already lined up, so all we need to do is multiply it by 4. Would the 4 be positive or negative? So we would say plus 4. And we're going to do this again. We're going to multiply 4 by our x plus 1. All right, guys, let's focus in. 4 times x is 4x. 4 times 1 is 4 plus 4. And again, just like we've been doing, we're going to put it underneath and match up our terms. And again, just like before, we're going to subtract. So 4x minus 4x is 0. 8 minus 4, 4. And like we've done before, we bring on the next term. Wait, is there a next term? Now, when you did long division with numbers, we would put a decimal and then add zeros and keep going. Here, we can't do this. This is as far as it goes. And what this tells us is that the 4 is the remainder. And what we do with the remainder is we do add it back in. So we do plus and we put a fraction. Okay? Are we ready for this? So what was the remainder? 4. It goes on top. What were we dividing this by? X plus 1, yes? It goes on bottom. And that's it. That's it. So it's just the same set of steps again and again and again and again. It is tedious. It does take a while, but if the remainder is 0, we don't have to put the fraction. Yes. Most likely no. But unfortunately, there's some things you got to do. It's just I mean, really, we could find areas, but it'd be very minute. Because if we know certain dimensions of it, or theoretical, you're talking about theoretical mathematics, you're going abstract. Oh, yeah. Mm-hmm. Question? Yeah. Questions on this here? Now, if the remainder is 0, so guys, if the remainder is 0, that number is 0, everything in this last line is 0, we don't have to put this, because the remainder is 0, it divided evenly, we would just have what was on top. Questions on this so far? All right. Let's look at the next one. We want to divide 2x to the 4th plus 3x cubed plus 5x minus 1 by x squared plus 3x plus 2. So what is going first is this here, our 2x to the 4th plus 3x cubed going down. Now, our first term is our 2x to the 4th. Now, we will need all the terms. I didn't mention in last one, but we do need those there. So the first term is our x to the 4th, which means our next term is our x cubed. And we have our plus 3x cubed. The next one would be our x squared term. What is our x squared term? Do we have an x squared term? No. But I can still add it in as 0x squared. Now we need it there just mainly because we are going to have x squared terms. We need something to hold its place. Our next term is our x term, and we do have 5x minus. So if there's a term missing, it doesn't matter if it's inside or outside. We add it back in as 0 times that variable. Outside, our biggest term is x squared. So we do have our x squared, our x, which is 3x, and our constant term. If we don't just have a number without a variable, we can add it in as 0. Questions on this here? Now again, one of the main questions, how do we know which one to start with? Well, how do we get our first number? How do we get that first spot? Well, again, when we start out with this or any of the steps, we're trying to get that first term inside our division to become 0, to get it to cancel out as we go down. So we're trying to see what times x squared, what times this x squared out here is going to give us 2x to the fourth. 2x squared. Because 2 is nice, because 1 outside, 1 times 2 would give us our 2. X squared, we need to figure out what times x squared gives us x to the fourth. Well, how many x's do we have outside? Here we have 2. Inside we have 4, because it's telling us how many times we multiplied it by itself. So I'm missing 2. So it would be 2x squared. Questions on this so far? Now this works as long as you do have all the terms inside our division, because we have our x to the fourth, x to the third, x squared, x constant term, yes? How many terms do we have outside that division symbol? 3, yes? If I go over 3, so we have the fourth, third, squared is our third one, yes? So our first variable should be squared, yes? Because it's what? 1, 2, 3. That's where we're starting. If that's true, let's look at the previous one. What's outside? How many terms do I have? 2. Yes? Yes, sir. Yes. That means we would go over 1, 2, and we start off with, we're just lining them up. Questions on any of this so far? So now we've got to multiply our 2x squared by our x squared plus 3x plus 2. We're going to distribute it through. Now 2x squared times our x squared. Well, we would have 2, because 2 times 1. X squared times x squared. When we multiply like bases, we have the exponents. So we get x to the fourth. 2x squared times 3x. 2 times 3 is going to be plus 6. X squared times x is going to be x to the third. All right, guys. 2x squared times 2 become plus 4x squared. And once we finish multiplying it out, we're going to put it underneath. And then we're going to subtract. Questions on this here? We're ready for our subtraction. 2x to the fourth minus 2x to the fourth. 0. That is exactly what we want to have happen. 3x cubed minus 6x cubed. 3 minus 6. Negative 3. And we still have our x to the third. Our next one is 0x squared minus 4x squared. 0 minus 4 is negative 4x squared. And then we bring down our next term. Questions on this here? Now we repeat the process just like we've been doing. We're going to try to figure out what times x squared, our term out front, is going to give us what? Negative 3x cubed. Well, what do we know our number has to be? Negative 3. Because 1 times negative 3 would give us our negative 3. What times x squared gives us x cubed? X. Because we have 2, we need 3, so I'm missing 1. Questions on this so far? Questions on how we got negative 3x? At this point here, we're going to distribute through. So we'll say negative 3x times x squared. We still have the negative 3. x times x squared is x to the third. Negative 3x times 3x, negative 3 times 3 is going to be negative 9. And our x times x is x squared. And lastly, negative 3x times 2 is negative 6x. Questions on this so far? Now, the first thing we need to subtract is negative 3x cubed minus negative 3x cubed. Now, again, for the most part, we can't do this in a calculator. But our coefficients, negative 3 minus negative 3, I can do that in a calculator, because negative 3x cubed minus negative 3x cubed, negative 3 minus negative 3 is indeed 0. Our next one is negative 4 minus negative 9. Negative 4x squared minus negative 9x squared. Again, I can say negative 4 minus negative 9, which tells me it is 5, positive 5. X squared, because our negative here would make a plus, so we're saying negative 4x squared plus 9x squared, which would give us 5x squared. And lastly, 5x minus negative 6. Well, the negative would make a plus. 5 plus 6 is 11 plus 11x. 5 minus negative 6 tells us it's positive 11. Can't type the whole thing in, but I can type the coefficients. I can type the numbers in front of the variables. And once we finish doing that subtraction, we bring the next term down. And lastly, we're trying to see what times x squared gives us 5x squared. 5. X squared is already the same, so we're just seeing the number in front, which is 5. And since it's positive, it will be positive 5. Positive 5x squared. We're going to do 5 times x squared plus 3x plus 2. And again, we're going to do the same process. We're going to distribute the 5. And the first thing we're going to multiply is our 5 and x squared. So our 5 times x squared is 5x squared. 5 times 3x is going to be plus 15x, and 5 times 2 is 10. Now 5x squared minus 5x squared is 0. 11x minus 15x. 11 minus 15, negative 4x. And negative 1 minus 10, negative 11. Do we have any more terms to bring down? No, so we're done with that there. Plus. We will have to put the remainder back in our answer. So we plus a fraction, negative 4x, minus 11 over our denominator, x squared plus 3x plus 2. Questions on any of this here? Questions on anything we've done so far? How do we feel about this here? A lot of steps, but a lot of the steps are repeated again and again and again. Yes? All right. Apparently I'm skipping problems. Make sure I go back and fix the note sheet. Yep. Oh yeah, no, maybe that one. Okay. Let's look at this one here. 4x to the fourth plus 5x minus 4 is being divided by x squared minus 3x minus 2. So inside our division symbol, we'd start off with 4x to the fourth. Our next one would be our cubic term. Well, we don't have one, so we'll add it in as 0x cubed. Our next term would be our squared term, but we don't have it, so we'll add it in as 0x squared. But we do have our 5x minus 4. So unlike the last one, we have to add that term in twice, that 0 term in twice. Once for our x cubed, once for our x squared. And what's outside is going to be x squared minus 3x minus 2. Questions on how we set this up, or what we've done so far? Now the first step is going to be the same. We're trying to see what times x squared will give us 4x to the fourth. Well, the number we know has to be what? The number in front of x squared is 1, and we want it to become 4, so we have to multiply it by 4. So 4 is going to go in somewhere here. Now the next part, what times x squared gives us x to the fourth? X squared, so it's going to be 4x squared is what we're starting off with. Questions on how we found 4x squared? Questions on how we found that first term? Now that we have it, we're going to take the 4x squared and multiply what we have outside, our x squared minus 3x minus 2. We're going to distribute through 4x squared times x squared, which will be 4x to the fourth, which is exactly what we wanted. 4x squared times negative 3x, 4 times negative 3 is negative 12. And our x squared times x is going to be x to the third. And lastly, 4x squared times negative 2, 4 times negative 2 is going to be negative 8x squared. And we'll match it up. We'll put it under our like terms. Questions on this here? Now our 4x to the fourth minus 4x to the fourth would be 0. 4 minus 4 is 0. Our next one, 0x cubed minus negative 12x cubed. 0 minus negative 12. The negative and negative make a plus. So 0 plus 12x cubed will be 12x cubed. 0x squared minus negative 8x squared. The negative and negative again will make a plus, giving us plus 8x squared. And we bring down our next term, our plus 5x. Questions on this here? Now we're going to repeat this process again. What times x squared will give us 12x cubed? 12 gives us 12 times, we do need 12. We also need what? X. Because our 12x times x squared should give us the term we want. Our first one is going to be our 12x times x squared. Because our 12 times 1 is 12. X times x squared would give us x cubed. Our 12x times negative 3x. Negative 3 times 12 is going to be negative 36. And x times x gives us x squared. 12x times negative 2. 12x, 12 times negative 2 is negative 24. X. And again, we're going to subtract. Negative 12x cubed minus 12x cubed. Negative 12 minus 12 is what? 0. 8x squared minus negative 36x squared. Our negative and negative is going to make a plus. So 8x squared plus 36 squared, x squared, is going to be 44x squared. 5x minus negative 24x, negative negative makes a plus, giving us plus 29x. And lastly, we bring down our negative 4. And we're going to do this one more time. What times x squared gives us 44x squared? 44. And since it's positive, it would be plus 44. And we do this again. And this time we're multiplying through by the 44. 44 times x squared. 44x squared. 44 times negative 3x is going to be negative. Well, we can do negative 3 times 44 in the calculator. It should give us negative 132x. And lastly, negative 2 times 44 will be negative 88. And again, we're going to subtract. 44x squared minus 44x squared. 44 minus 44 is indeed 0. 29x minus negative 132x. Negative negative makes a positive, giving us 161x. Here, negative and negative again makes a positive. Negative 4 plus 88 is plus 84. Again, we put the remainder over what we were dividing by. Questions on any of this here? Questions on anything we've done so far? How do we feel about this here? Would we say that there's a lot to it and not a lot to it all at the same time? Because there's a lot of that repeated process again and again. Any questions on any of this here? I know that there's 3 left that we have. I want to look at this one here before we wrap up. X to the 4th plus 4x squared minus 45 divided by x squared plus 9. There's a few reasons I'm looking at this here. One of them as well. Again, inside what goes first is our x to the 4th. We don't have an x cubed term, so we can add it in as 0x cubed plus 4x squared. We don't have an x term plus 0x minus 45. Because again, if we're missing terms, we will have to plug them in as 0x. If we look at what goes in front, We have x squared. We don't have an x term, so we need to plug it in as 0x plus 9. Because again, we need each one of these terms here. Now, for the most part, when we do the multiplication, our 0x is going to be, well, 0 times whatever the x is. And we can do our division here. Yep. Now, the first thing we're going to do is see what times x squared gives us x to the fourth. X squared. We have 3 terms. We can go over 3 terms, so we'll know we'll have x squared, yes? I think y'all notice the pattern. The next term is going to be some number times x, and the one after it's going to be a constant term. We kind of have that x squared, x constant. If it started out with x to the fifth, x to the fifth, x to the fourth, x third, x squared, x constant, it will decrease in this pattern. But yes, the only thing we need there is x squared. And we'll do our multiplication like we've been doing. X squared times our x squared plus 0x plus 9. X squared times x squared is indeed x to the fourth. 1 times x to the fourth, or x to the fourth. X squared times 0x. Well, the number will indeed stay 0, yes? Our x times x squared would be x cubed. We still need it more as a placeholder than anything else, so we can match up our like terms. And our last thing is x squared times 9 is plus 9x squared. And we'll put it under their matching terms, x to the fourth plus 0x cubed plus 9x squared. And then we're going to subtract. X to the fourth minus x to the fourth is 0 like we wanted. 0x cubed minus 0x cubed is 0. 2 ways we can do this. One is I can leave it as 0x cubed. 4x squared minus 9x squared is going to be negative 5x squared. Let me bring down our next term. Now, if you don't want to leave it as 0x cubed, that's fine. We can just say that it is 0, yes? Okay. If we leave it as 0, we don't write it in. How many terms do I have down there now? We have the x squared term and the x. I have what? 2, yes? How many terms am I dividing this by? 3, because I have my x squared, my x, and my constant term, yes? Do I have enough terms here? No, so we have to bring down the minus 45. And the reason this works is because, well, our x term is really 0x. There is no x term there. Does that make sense? So we could have left it at 0x and gone through and multiplied by 0 and subtracted. I'll show that here in a minute. Questions on this so far? So really, if that first term and the second term becomes 0, we can zero it out, but we have to bring down another term. Instead of 1, we bring down 2. Now, what times x squared gives us negative 5x squared? Negative 5. So now we're going to multiply through by negative 5. Negative 5 times x squared is negative 5x squared. Negative 5 times 0x is what negative, or plus 0x, because it's just 0. And lastly, negative 5 times 9 is negative 45. last but not least, we're going to subtract. Negative 5x squared minus 5x squared. Negative 5 minus negative 5 is 0. Be 0. Well, 0 minus 0x is still just 0, yes? Negative 45 minus negative 45. So here the remainder is 0. So x squared plus 0x minus 5 is our answer, or we can just say x squared minus 5. We don't have to leave the 0x terms there. And that's it. So if it is the remainder is 0, we just write what's on top of that division symbol, so the x squared minus 5x, or x squared minus 5. That's it. Questions on this here? Long division, I would say, is not bad, it's tedious. It's a lot of little steps. We're just repeating the same process again and again and again as we go through until we can't do it anymore. 6 problems. That's it. 5 through 10. 6 problems you need to do by long division.